So far we have considered only unsigned binary numbers that represent positive quantities. We will often want to represent both positive and negative numbers, requiring a different binary number system. Several schemes exist to represent signed binary numbers. The two most widely schemes employed are called sign magnitude form and 2's complement form. First, we will go through sign magnitude form. In sign magnitude form, numbers are intuitively appealing because they match our custom of writing negative numbers with a minus sign followed by the magnitude. An n-bit sign magnitude number uses the most significant bit as the sign and the remaining n-1 bits as the magnitude or absolute value. A sign bit of 0 indicates positive and a sign bit of 1 indicates negative. In example 3, we will write 5 and -5 as 4-bit sign magnitude numbers. Both numbers have a magnitude of 5 base 10, which is equal to 101 base 2. Thus, positive 5 base 10 is equal to 0101 base 2 and negative 5 base 10 is equal to 1101 base 2. Here 0 represents positive and 1 represents negative. A range of n-bit sign magnitude number spans from -2 raised to power n-1 plus 1 to 2 raised to power n-1 minus 1. For example, a 3-bit binary number spans from -3 to +3. Sign magnitude numbers are intuitively appealing, but they have some shortcomings due to which they are not much used. The first shortcoming of sign magnitude numbers is that ordinary binary addition does not work for sign magnitude numbers. For example, the sum of -5 base 10 and positive 5 base 10 should be equal to 0. But using ordinary addition, the sum is 10010 base 2, which is a nonsense number. Second shortcoming of sign magnitude numbers is that both positive 0 and negative 0 exist in this system, which is odd. Both positive 0 and negative 0 indicate 0. This is the end of our lecture. See you in next video.